this summer, and one thing to know about Nitya is that she's really passionate about problem solving. I remember one time it was end of a Friday session and there was something not working. I was like, okay, it's okay. You can just work on it on Monday, right? And then Monday she comes in and immediately she tells me like, oh, I actually found this resource online over the weekend that might help a lot. And yeah, that resource was actually really helpful. So I was really impressed that she took the time out of her weekend to work on her museum project, and I think you all will be really impressed with her project. So please
Hi, my name is Nitya, and I'm an incoming junior at Brook High School. And this is my project, the Hexapod, which is basically a six-legged robot that is connected to like a Arduino board and is connected through these black acrylic plates. So I chose this project because I thought it was really cool and versatile, and I thought I could learn a lot about robots and sensors from it. So the way it works is it has these servos, which are basically responsible for its motion. And there are 3 servos for each leg, and there's 6 legs total. And each servo is responsible for a different kind of motion. So for example, this servo can move its leg up and down, and this servo can also move it like kind of up and down as well. And this can move it side to side. And through combinations of these movements, the hexapod can move in all kinds of directions and ways. For the modifications, I added 2 ultrasonic sensors so that the robot, ultrasonic sensors are basically a kind of distance sensors, which can sense how much distance is between an object and the sensor, so that way the hexapod can move by itself and navigate through objects in each way. So I'll give a short demo now. And also, it also has this remote controller, which can send commands to the hexapod through these switches and potentiometers. And the way this remote controller communicates with the hexapod is through this wireless module, which transmits radio waves to another wireless module on the hexapod. And this communicates to the board through the SDI interface. So I'll start the demo now. So here you can move forward, backwards, right, and left. And by using the different switch, you can make it turn right or turn left. Yeah. It also has this cool function where it can like kind of twist its body. And also can change its height as well. So I also modified the remote so that when this joystick is pressed, the hexapod code starts using the ultrasonic sensors to sense objects in its way and move according to that. So for example, if I put my hand here, it'll start it'll move forward. If I put my hand here, I'll start moving backwards. And for example, in the case that it senses something in both directions, it'll just start moving right and so it'll start moving right until it senses an opening for it to move. So, and in the case that it continues turning right and it never senses an opening, it's supposed to go into sleep mode after training for 180 degrees. And while building this robot, I faced a lot of challenges. For example, while I was assembling the robot originally, I screwed in the servos backwards, and that caused them to caused the legs to keep on falling down and never hold their position. But I realized that once you're screwed on correctly, they should make this buzzing sound. So that's how you know that you're screwed on correctly. And also, another big challenge I faced was while integrating the code for the ultrasonic sensors into the default robot code, and this is because the original default robot code contains a function that can only run by itself, and whenever you try to add anything else to that, it creates delays that mess up the pace of the program. So I had to edit the library itself and add the ultrasonic sensor code into that library. At my time at Bootcamp, I've learned a lot about sensors, specifically ultrasonic sensors, and how to code and wire components. And in the future, if I had more time, I would want to add more sensors and continue improving the current modifications I have.
make stuff with wires or rectangles or.
Yeah, and a solution to that is that there's this thing called like a cable tidy, which you can wrap around the wires so that they can be organized for each circle.
You have to like coordinate all the legs, or is that like presuming they have to move in a specific fashion for it to?
There is code for that, but that was like part of the library that I did.
How many motors do you have in this?
This doesn't use motors, it uses servos, so there's a total of 18 servos.
Building on that question, so you have code to, how does the library work with it, where you know what the different positions the servo should get into to move forward, backward, in different directions?
Can you repeat that?
So, how do you know in which direction to move the servos so that it goes in the different directions, since there's 3 servos per leg? So that seems a little complicated.